Over the last few tutorials we've come across the Comp3D effect. So in this tutorial we'll have a good look at all of the functions it has internally. Just to start with, what I have is a still of a sky which has a full alpha channel and just a background grey. So as we can see, and as we've used in the last few tutorials, the Comp3D is compositing the sky and its alpha channel over the background. The reason we don't see the background at all is that the sky's alpha channel completely covers the frame. But actually there's a lot more going on here than just a simple composite. As we looked before, the Comp3D title tells us the two things this effect does. It's a compositor, but also it works in a 3D environment. By 3D environment we're talking about a virtual block of 3D space where there is width in X, height in Y, and depth in Z. And in that 3D block of space there are at least three things. Firstly, there's a camera, and by default we're looking through the camera into the 3D block of space. Secondly, there's a light source. And thirdly, there's a layer, which is an image plane, and that image plane carries the input that we provided from the timeline. Now we can start to see those elements if I pick orbit and drag and then dolly to come out. We're still looking through the camera, so we don't see the camera, but we can now see the plane on which our image layer is present. We can also see the light that's lighting up this image. So the key concept about Comp3D is that we're working in a 3D environment in which we can place images in varying locations and light them and move the camera around them. So let's just reset our view. And firstly, let's look at the layer. So layer 1, as its default name says, relates to the first input to Comp3D. The inputs to Comp3D by default are firstly a background, and thereafter the layers counting upwards as we go away from the Comp3D. The background is a static entity. It never moves. No matter where we place the camera, it'll always be in the same place. So let's look at how we manipulate a layer. If we open up folders, we can see some subfolders inside, and the first one is transform. So within transform we can position in X, Y and Z, or rotate, or size, or change the pivot, which is the axis of rotation. To keep our minds in 3D space, here's an interesting comparison. By changing the position in Z, I seem to be making the image smaller. In the same way that if I go to size and change the scale, I seem to be doing the same thing. So what's different between the two? Well, when I change the position in Z, I'm actually not making this smaller. It's getting further away. And how we can prove this is if I go to orbit, look at an angle, you can see that if I change the size, the plane is staying in the same place, just getting bigger or smaller. On the other hand, if I change the position in Z, you can see it's going further away from the camera. So as we can see, we can manipulate the position of the plane by sliding the numbers as we do on any Mistika parameter, with Shift, Control and Alt all changing the scale at which we change the numbers. Or we can type numbers in, or there are graphic manipulators as well. In terms of the number system, they're reasonably obvious. Rotations are in degrees, so 45-degree rotation. Size is in percentage, that's now 10% wide. But pivot and position perhaps need a bit more of explanation. The values in here are not absolute. They're relative to the aspect ratio of your image. The reason for this is that there are some circumstances where you might work in multiple resolutions. For example, you might be grading in 2K, but will do your final output in 4. In those circumstances, if these numbers were absolute, if you moved something 500 pixels to the left, that would be a different position between 2K and 4K. So these numbers relate to the aspect ratio, which generally doesn't change. If we think of the aspect ratio of this is a 16:9 image, so it's 1.77 to 1. The size of the image in the units that we would enter into X and Y here is equivalent to 200 times the aspect ratio. So if this image is 1.77 to 1, 1 being the height in Y, if I put in 100 into Y, it would jump halfway up the screen. And if I put in 200, it'll go all the way up the screen. Likewise with X, being 1.77 to 1. If I type in 177, 100 times the aspect ratio width, then you can see the image moves halfway along. And if I double that, so 200 times the aspect ratio width, the image moves the same distance of the width of the image. We can also use these manipulators and constraints to control the position of our image. So again, let's just make an offset just so we can see what we're doing. It's good practice to select the layer that you want to move. If you have multiple layers, you can either select them manually, or if auto select is on, then whichever layer you click on will be selected. So in this instance, I'm going to be moving layer 1. With free transform on, just moving around with left mouse button or pen tap down gives me positional. Holding down Alt will rotate, and holding down Control will scale. I'm just going to turn off axis at the moment. We'll come back to what that means later. And I'm just going to put the arcs on, which shows us our axes of rotation. We can use these axes to help us control as well. If I hold down Shift and click on one of the arms, as it were, you can see it highlights. So this is now applied a constraint, so it doesn't matter what I do with the mouse, it's only going to go in that direction. Likewise, if I rotate, I can pick the particular axis of rotation, and now it's only going to rotate in that axis. We can also set constraints here. So constrain in X. No matter what I do with the mouse, we're only making an X change on the picture. And that's its local X change. So that's the X with relation to the screen plane. Or I could reverse that. So now the movement will be everything but X. Regarding the axis of rotation, I'm just going to reset everything. With no constraints on, and using either Alt or this rotate function here, we can see that as we rotate, we're rotating along the Z-axis, and you can see clearly that only the Z-axis is changing. Now, if I move our camera position around and do the same thing, you can now see that all of our parameters are changing. The reason being is that without any explicit constraints on, the rotation manipulator works along the axis of the camera. So this is working out what parameters have to change in order for rotation to happen around the direction in which the camera is pointing, if you like. If I explicitly wanted to rotate around the plane's axis, then all I need to do is enable one of the constraints. And now, as you can see, it's only adjusting the Z-axis. So in terms of the controls on this side, this column controls whichever layer is selected. This column controls the camera position. And we have our constraints here, as we saw. Our view is normally from the camera, but we can also view from a number of preset positions. So for example, viewing from the top, if I zoom my display down, we can see we're looking down. So we can see our plane, which carries our image. we can see our light here, and we can see our camera here and the field of view that it has. We can choose what we're going to display. So I could hide the lights, I could hide the floor, hide the axes, arcs, hide everything. Hiding the layers just hides the highlight around the layer. Let's go back to camera and reset our view, cancel our scale. And just while we're here, these two functions here, resize 1:1, if the input isn't the same resolution as your mastering resolution, then clicking this will populate the scale in the selected layer to make sure the image goes with a 1:1 pixel ratio. Then, as we mentioned, auto selection is if you have multiple layers, you can just click on a layer and this will highlight up accordingly. So I'm just going to press delete to go back to a neutral setting. Let's investigate a little further what goes on in layers. So for each image plane, for each input, we have a layer. And we've seen that we have position, rotation, size and pivot for each one. Pivot is just an offset. So for example, if I wanted to rotate around that particular cloud up there, then by changing the pivot position, now when I rotate, it's rotating around that point. Under attributes, there are a few functions to control the layer. We'll come back to these when we look at displacement mapping. We already briefly looked at the blending mode. So anyone familiar with Photoshop will be familiar with these methods of combining. Specular and gloss controls how the layer reacts to lights. We'll look at that when we look at lighting in more detail. An attribute blend is the opacity of the layer. And as with every parameter always with Mistika, under curves, anything can be given a graph to animate. Under deform, displacement map we'll come back to. Torus allows us to bend our image in various directions. So this one will bend it around the y-axis, this one will bend it around the x-axis. If you find the right numbers, you can make yourself a perfect ball. The quad changes the curviness of the bend. So you can see we can turn it into more of a box shape. Whereas the radius is just that, the radius of the turn. Wave offers us basic displacement mapping, so it gives us an amplitude from an X wave, so we can push our image in and out. We can animate the phase of the wave for your instant waving flag effect, and we can change how many cycles there are. Likewise, there's one for Y. And as you can see, we're creating a full 3D piece of geometry when we work this way. All these methods can be combined as well. So this is bending it as well. Let's get back to something a little more ordinary. Crop, as you'd expect, just crops the layer. Strictly speaking, it crops the alpha channel of the layer. So if this layer had an alpha channel, then by default the area inside the alpha channel will be keyed over the background. The area outside would just see the background or the other layers behind. then corners allows us to control the positions of each corner individually, and this is mostly used with motion tracking to track a perspective object. But we can also do it here, either by changing the values or selecting 2D and selecting our corner, so our upper left corner we can place wherever we want these to be. So it allows us to match perspective shapes. Just going to delete that, and let's just resize that down a little. Let's jump up to shadow. Shadow is a very simple shadow maker that just projects onto the background from all the layers. So you can say its intensity, where it is positioned, what type of blur it has, how defocused it is, and so on. Spread pushes the shadow out, so if you have a particularly blurred shadow, obviously it becomes more and more faint, so spread will allow you to push the shadow out. Under options, a couple of things to know about in here. So far we've always said that the first input to a Comp3D is an unmovable background. Well, that's not entirely true. If you switch this off, then in fact the very first input to the DVE would be the input to layer 1, and the background doesn't apply at all. Mode, you'll almost always have it in hardware, meaning all the calculations are done on the graphics board. If there's any particular problem with that, you could switch to software, which will be slower. On rare occasions you might switch to this. As with everything in Mistika, it's optimized to work very quickly for 99% of what you'll do. There are some situations where you might see some clipping occur because, for example, something has gone way off into the distance in terms of its Z depth, in which case if it's clipping on hardware it probably won't clip on software Z. Samples has two functions. By default it's an anti-alias. So if I rotate this image, scale it down, zoom right in, we can see that we could improve our result by increasing the anti-aliasing if we ever see any aliasing coming in. The higher the number, the longer it will take to process. The other thing that we can use samples for, in combination with shutter, is to create motion blur that's accurate to the direction our animation is working in. So let's quickly make a simple piece of animation. So we'll put up our auto key. So that will be on our first frame, that'll be on our 24th frame, and that'll be on our 51st frame. So we have this piece of animation going on. If I set the shutter angle to 180 degrees, this relates to cameras, so those of you that understand camera technology will know what this means. It's basically how long the shutter is open for within its cycle from 0 to, well, a theoretical 360 degrees. But the higher the number, the longer the exposure time. So with it set to 180, we can see that actually nothing has changed. The reason being is the samples are set to 1. We need to increase the samples in order to allow Mistika to calculate the motion blur. Now if I put it just onto 2, we can see that we're starting to get a double image. If I pick it in the motion, we can see that everything's gone double. The reason being is that Mistika's calculating the move twice and superimposing twice from the number of samples. To get a smooth motion blur we'll need to be a lot higher, let's say 15. So now we can see that we're getting a motion blur that's reacting properly with the direction change. Let's just insert another keyframe down here just to make it even more obvious. So you can see the motion blur is properly following the direction of travel. If you see steps in your motion blur, like that, it's simply that this number isn't high enough. You might want to jump to the highest number, which will certainly give you the smoothest motion blur, but it'll also take the longest to render because you're effectively telling Mistika to calculate that moves 66 times. Under the camera folder, we have the main positional information for where the camera is and where it's pointing. And up until now, I've just been moving around with orbit. As you can see, it's changing the parameters. If we use an external camera tracking system such as Synthesize, then it will apply its data into here. Other useful things within the camera: we can roll the camera as well. We can change its field of view, so this is in degrees at the moment, so we can make it more wide angle or less. The camera interocular allows us to have a stereoscopic pair of cameras within the environment. So if I went into stereo mode and just put myself onto anaglyph, then we can see that if we start adding in some interaxial, we get a proper left and right image. And that left and right image reacts properly to the Z position. You can see it's changing as we go in and out. We'll have a look at the lighting in a more advanced tutorial, but by default what you'll find is there are two lights effectively in the scene. There's an ambient general background light set at 33%, and there's a directional light set at 67%. A directional light is completely uniform. We'll go into that in more detail, but just suffice to say at the moment that the reason when we come into a Comp3D and key something that the layer comes out the right color is that it's got 67% of directional light and 33% of ambient light. Add the two together, 100% light. This is also why we get a darkening effect when we rotate. So if I rotate in the Z-axis, you can see how the image seems to be going darker as it rotates around from us. The reason for that is it's now angled away from the directional light, which in fact is from the same direction as the camera by default. If I didn't want that to happen, what I could do is set my ambient lights to be 100%. So now that's not going to have any effect. Now let's just have a look at how multiple layers work within the timeline and within the interface. So I'm just going to go back on this. In fact, I'm going to delete Comp3D because I'll just put another one in a second, so I know that we're back to default settings. And let's just put in a title that says layer 1. And over both of those, a default comp. Now, what we can see so far is that in default we have a Comp3D, we have the background it's keying over, we have our sky, and we have the title. The reason we can't see the background is the sky layer has a completely opaque alpha. The reason we can see the sky behind the title is if we look closely at the title, by default it's giving us a white on black video. It's also giving us a white on black alpha, so the black bit doesn't key. Now, although I've got two input layers, I only have one layer in my manipulators. So that means that if I were to start changing this around, we can see that those two layers are actually stuck together. Those two different inputs have been comped together to pipe into layer 1, which is Mistika's default behavior if there's a discrepancy between the number of input layers and the number of manipulator layers. If I wanted to have them on separate controls, all I need to do is just add another folder or another layer, or duplicate the one I've got. So let's just duplicate this. Nothing seems to have changed because of course the two parameters are the same, but now I, for example, could move the text layer forwards or backwards. And you can see as I move it backwards there's a point when it'll just disappear. The reason being is that it's disappearing behind. Let's look what happens if I add a third layer in. So I'm going to duplicate this title, but I'm going to change it to be more text. And just make sure that the scope of the 3D effect encompasses all my inputs. The easiest way to do that is to drag it all the way down to the bottom and back up again, because the scope stays at the lowest point. So now we can see that our text has got combined, and it's combined on layer 2. See, if I move this around, it's moving both. The reason being, again, we're back to having a discrepancy between the number of inputs and the number of manipulator layers. So here I've got 1, 2, 3 input layers, and here I've only got 1, 2 manipulator layers. So what Mistika is doing is it's assigning the first input layer to layer 1, the second input layer to layer 2. Then it goes, okay, we've got some left over. So what it'll do is it'll comp this, it'll pre-comp this with the last usable input. So effectively, layer 2 in this instance is a pre-comp of layer 2 and 3 of the inputs. And again, obviously, if we wanted to have a separate set of controls, as we did before, just add folder, and now I have layer 3. So I've got layer 3, layer 2, and layer 1, which are all sitting in their respective 3D positions. To make manipulating them easier, if you double click on any of these, you can actually rename them. So this is our sky. This we'll call text, and this we'll call more. So we can make it a little easier to get hold of. And also, this is now where auto select becomes more obvious, because now by clicking one of the layers, we can see that we can access the individual layer just by grabbing what's on the screen. So up until now I've been avoiding these axes controls for no other reason than this is the best time now with a few things up on the screen to play with them. They're pretty straightforward. As we know, in the layers we've got a transform folder that has position, rotation, size and pivot. If I look at axis 2, we can see we've got the same, and in axis 1 again the same. Effectively, these are offsets to the positional information that's set in a layer, but they act in a hierarchy. So all the layers have their individual positions. So for example, the sky's X position there. If I were to change the X position of axis 2, you can see it actually changes everything, because it's a universal offset applied to all the layers equally. But then likewise, axis 1 is a universal offset that's applied to axis 2 that is then applied to the layers. So it just allows you to have control over multiple layers, and the most often use for axis would be to add in motion tracking information. So that's pretty much covered most of the key features within Comp3D. We'll have a second tutorial about some advanced stuff such as displacement mapping and using the lights. There's just one more thing that I'd like to point out in terms of how the Comp3D reacts on the timeline. If I just move ourselves around so we can see those 3 layers. And I'm going to make an alteration on the timeline. I'm going to shorten this first shot to here and go back in. So initially, all is as we left it. But if I drag on to the point where we know that on the timeline this sky shot runs out, we can see that everything's jumped position. The reason for that is this. At this point, you can see the sky is no longer there. And because of the way Mistika works in trying to be helpful and trying to be non-rigid in how we use these tracks, we're free to put inputs anywhere on the tracks as long as they're in order. So that is just as valid, because Mistika doesn't look for a particular track to find an input. Rather, it simply counts away from the effect. So 1, 2, 3, 4. It doesn't count these. But this does give us a problem in this instance, because as this disappears, before the cut, the Comp3D accepts background, layer 1, layer 2, layer 3. But after the cut, it'll go background, layer 1, layer 2. And that's why, as we go over the join, you can see that the layers are actually descending by one in terms of the properties that they're taking. Now obviously this has the possibility of getting pretty confusing. So generally try to avoid this situation where the number of inputs changes. If you can't avoid it, there's two ways around it. Let's say we really did want the sky just to disappear. Well, either we could keep it full length, and at this point we could simply keyframe the opacity of that layer from 100 to 0 across a frame and it would disappear. The other thing that we could do is if we insert solid here, which as we'll know from other tutorials is just a solid black, but actually it sort of isn't a solid black, because if we investigate the parameters, you can see yes, it's black RGB, but actually its alpha channel is also by default 0. So when we look at this in context of our comp, we can see that now we're getting the desired effect. The sky is just disappearing. But you can also see by the outline of layer 1 that layer 1 isn't disappearing, it's still there, it's just being filled with black that has no alpha channel. So it acts as a padding. So in the next tutorial we'll have a look at some of the more advanced features within Comp3D.